All right, so what we're going to do is starting with today with polynomials, linear factors, and zeros, is we are going to start with, well, straight up, where this started. This started because people wanted to sketch graphs when Rene Descartes came around with the idea of just working with actual graphs and stuff, and they wanted to work with some polynomials, and they were going, okay, how do we do this stuff? And so what they did was, and this was from the idea of factoring, and there was an interesting one. There was a guy back in Italy, Vince. Now I want to say Vincent Tartaglia, but I don't know. Tartaglia, someone Tartaglia, and they actually found out how to do this stuff, and they found out that synthetic division and long division, which you'll learn about, are the ways to actually do this. Okay. All right. So something that looks like this. So let's say we had x to the third minus 2x squared minus 15x. Okay, let's say we had something like that. All right, now if I had to write this in factored form, I would check it first. And this is where you want to use, on the message boards, you want to look up the factoring flip chart or the factoring flow chart. Okay, so first off, I'd look, do they each have something in common? Yes, they do. They all have x's in common. So I factor out an x, and I'm left with x squared minus 2x minus 15. Okay, and then I would ask myself, can I factor the trinomial in there? And I could, so I do. So I get x minus 5, x plus 3. Okay, and so I'd factor it like that. And so when Tartaglia said we could actually factor higher order polynomials, and they found out later on that it's really kind of hard to do if you had a degree of 6 or something like that. They sat down and they said, okay, how do we factor this stuff? How do we work with this? And there was actually a real stuck spot. Okay, all right. But first off, we're going to understand how this works, what this actually does. Okay, so normally what we would do is we would solve this, okay, for x. We'd actually find out what x is. X is 0, or x is 5, or x is negative 3. Okay, so we actually find out 3 of these numbers, but what are these numbers actually telling us? And so that's what people wanted to know back in the day. Okay, and so we just talked about end behavior and everything. Okay, how do we graph this? So this is some interesting stuff here. Okay, so first off, I look up here, a is greater than 0, and degree is odd. Okay, so since it's odd, all right, we know that the end behavior, and we'll talk about that in a second, is going down and to the left and up and to the right. Okay, now if you remember, I said, what about the rest of the graph? Okay, that's what we're going to use today. All right, so the rest of the graph is saying we cross, when you solve a polynomial for x, you're actually finding the roots or the zeros or the x-intercepts of the actual graph. Okay, so right off the bat, I know that it crosses at 0. I know that it crosses at negative 3. Okay, and so we got another cross here. And I know it crosses at 5. Okay, I also know that it goes up and to the right and down and to the left, okay, somehow. Right, now if you notice, I can kind of connect these two, and I know that it's going to come from that, so there we go. Okay, so that's kind of simple, but where does it go in here? So this is where I actually have to plug in some points. And so what I might do is I might plug in values. I might plug in, something simple like, I already have 0 in there, so I might plug in something in here. Let's go with negative 1. So we plug in a negative 1, and it doesn't matter where you plug in a negative 1. It doesn't matter if you plug it in here or in right here, as long as you plug in the right number and then you solve it. So I'm going to plug it in right here. So negative 1. Okay, when you raise negative 1 to the third power, please understand that you're multiplying -1 3 times. Okay, minus 2 times parentheses -1 to the second power minus 15 times -1. Okay. All right, so if I go -1 to the third power, that turns into a -1. Okay, minus 2 times -1 squared, so that -1 squared becomes 1, so that becomes minus 2 still, so that's pretty simple. And then this 15 times -1 is -15, but then I have that minus here, so it's going to be plus 15. Okay, and so -1 minus 2 is -3, plus 15 is 12. Okay, so I'm going to graph the point -1, 12, and so that point is going to be up here somewhere. Okay, so now that I know it's going up here, okay, I know that it has to come back down through here. Now this is just a very rough graph drawing. Okay, now I'm going to test some number in between, right? I'm going to test 2 just to mess with it, and I'm going to show you how to plug in 2 right here. So I'm going to plug it into the factored form, so it's 2 times -3, because 2 minus 5 is -3, times 5. Okay, and this one's a lot easier to work with. So 2 times -3 is -6, times 5 is -30. Okay, so I know that that point is going to be way down here. Okay, but I know that once I go down there, I'm probably going to be coming back up through this one. All right, and that's how you graph. That's how you used to graph back in the day. Now, today we have these amazing things called graphing calculators, and they do it a lot easier. So when I actually put it in, y equals x to the third minus 2x squared minus 15x. Okay, and if I zoom out, I can actually see that that's pretty darn close to what I needed. Okay, so there's my zeros, and if you see, it goes down to -3, -36. It just works that way. So I got a pretty rough sketch of what it's actually doing. But the cool thing is that I was able to do that all by hand and just get a very rough sketch of what this graph is actually doing. Okay, so you can use this to work this way. Now, what we also need to understand is we need to understand some terms over here. Okay, so first off, the most basic ones, relative max and relative min. Okay, relative max is going to be it's kind of like the top of the hill right here. Okay, so the relative max is going to be right there. Now relative min is going to be down here at this lowest spot. Okay, all right, now the reason why it's not called an absolute max or an absolute min is because these points are higher and these points are lower, so therefore they're not there. But on this scale right here, all right, these are actually the relative max and relative min to everything else. Okay, so that's really kind of cool. Now, the factor theorem is actually this one right here. So the factor theorem we've actually done. The factor theorem is where you find the factors of a polynomial function, and you can actually find the zeros or the roots or the x-intercepts, whatever you want to call it. So the factor theorem is actually explaining how we got these. So that's pretty cool right there. Okay. All right, multiply 0, don't need that one as much, but multiplicity is actually kind of cool. Okay, now multiplicity is when you get multiple answers of the same thing. So like for example, if I had y equals x squared plus 4x plus 4, and if you notice when I factor it, I get x plus 2 squared, and then if I solve that for 0, I'm going to get x equals -2 right there. But interestingly enough, what happens is when I actually graph it, okay, my curve is actually hitting that point. Okay, so when you have a curve that hits this point, we call that a multiplicity of 2. Okay, right? So this would be 2 with a multiplicity of, or negative 2 would be the answer with a multiplicity of negative 2, because that means it happens twice. There's 2 answers that I could plug in. Okay, well, no, not 2 answers. There's going to be 2. It's going to hit a bump. Okay. So if I know something has a multiplicity of 2, so let's say that I knew what my roots were. So let's say my roots, or zeros, or x-intercepts are equal to 2, comma 2, comma negative 4, comma let's go 6. Okay. So what this is going to tell me is I can actually tell you what the actual function is going to look like from this. Okay, so if I graph it right here, okay, I know that I'm going to cross at negative 4, so 1, 2, 3, 4. I'm going to cross at 2, and I'm going to cross at 6. 1, 2, 3, 4. Okay, so I know I'm going to cross at those. Now, because I have 2 twice, that means I'm going to either cross the graph and touch it and go back up, or cross it and come back down. Okay, now I know, and this is just a rough sketch idea, and I'm not going to be 100% exact, because this could be, you could reverse the image and it would still be true. Okay, now because I know this, okay, I could have the graph look like this. I could, and here's another thing. The amount of answers you have will tell you the degree in kind of a random. It doesn't tell you the exact degree, but it tells you a rough idea of what the degree is. Okay, so the degree, since there's 4 answers or 4 roots, the degree is probably going to be 4. That's my guess. It could be something different. It could be something really weird. Okay, so since the degree is 4, I'm going to go like this. We know that the degree is roughly going to be 4, so it has to go up and to the right, up and to the left. So I'm going to say it's going to go down through here, and then when it comes back up, it touches, and it comes back down, and it goes back up. Okay, and it's a curve type of motion. Okay, so let me get rid of that so we can get a better curve. So something that looks like this. Okay. And that way I know it could be that way. Now, if the degree was 4 and it was negative, let's say the first coefficient was negative, okay, well, that would get rid of this part up here. Ugh, so much tediousness. Okay, and if it was negative, it would be going down and to the left and down and to the right. So it'd go up like this, curve, hit, and then come back down. So that's what a multiplicity does. It actually tells you where the actual, I guess you could say, lump of the graph actually hits it. Okay? All right, now if we look back at this one, okay, if this had a multiplicity of 2, if this one had a multiplicity of 2, our graph would look like this. Okay. All right. Now the sucky thing is that would mean that this is untrue, so you know that would obviously disappear. But this one would actually have 2 answers to it. Okay. All right. But that is it for pretty much everything you're going to be learning about this stuff. One thing I do need you guys to know is that you can actually go from the roots to the actual answer. So if I know my roots are this right here, I would write out x minus 2, x minus 2, x plus 4, and x minus 6. And if I multiplied this stuff all out, if I did FOIL all the times, I could actually get the actual polynomial from it. And that's just from knowing the roots. Okay, and that's one method to work with. Thank you guys very much and have a great day. Bye.